Hello learners, welcome to education program online. I am teacher Christine Adekur, taking you in mathematics for senior 3 and senior 4 classes. Our topic for today is application of differentiation. So the previous lesson we are looking at the implicity of functions, and today we are looking at application of differentiation. How is a differentiation applied in everyday life or in mathematics? So we are starting with what we call the stationary point application of differentiation on stationary point. Stationary points. Stationary point. So a stationary point, what do we mean by stationary? Stationary simply means being in a fixed point. So when you look at a stationary point, we are looking at a point where the gradient is equals to 0. Where the gradient is equals to 0. So we say a stationary point is a point where at which the gradient is at 0, at which the gradient is at 0. The gradient is at 0. So this is what we call a gradient, a stationary point. At such a point, a tangent to the curve, is parallel. The tangent to the curve is parallel to the x-axis. That is to say, dy over dx or f raised to 1 equals to 0. So what happened here, you will find that we may look at our curve here, and then you see how the gradient is parallel to the x-axis. We have up and down and so on. So you will find that we have these points, we have this point, we have this point. This is the y-axis, this is the x-axis. You can say this is our starting point 0, and then we have at this point you find dy over dx is greater than 0, and then here dy over dx is equals to 0. At this point, dy over dx is less than dy over dx is less than 0, and then we have this point is where dy over dx is equals to 0, and then here we have dy over dx is greater than 0. So learners, look at this curve. We said a stationary point is a point at which a gradient is at 0. The gradient is at 0. A point where you go up and then you come down. At certain point, you'll find that at that particular point where you at a 0, at a fixed point, you'll find that the x-axis or the tangent is parallel to the x-axis. What is the tangent? A tangent simply means a point of contact. A point of contact becomes parallel to the x-axis. So when you look at it, in mathematically, we say dy over dx or f of 1 equals to 0. When you find f of 1 equals to 0, just know that this is now a point at which a gradient is 0, which is a stationary point. So our curve keep on moving in this form. We have the y-axis and the x-axis. So you'll find that you will start from 0, climbing. This is a point when you are moving up. You'll find that the gradient at this point is greater than 0. And then as you reach to a certain point where you can no longer continue up, then you begin to slide down. So as you slide down, you will reach a point where you can no longer move anymore on the downward. That is at a slope here. So when you reach at this point, we say this is the point where you are fixed. And this is where we say it is a stationary point. The gradient equals to 0. So no matter, even if you reach to that fixed point, a time will come when you can again still raise up and you move up, which is as you move up, then the gradient becomes greater than 0. So when you come down, the gradient becomes less than 0. So when you reach to a fixed point, the gradient becomes equals to or becomes to 0. So this is simply how the stationary point illustrates it on a curve. So looking at this kind of a graph, you find that or a curve, you find there are 3 types or 3 categories of of stationary point, because you have seen from 0 here at a starting point you were climbing, and then you reached at a certain point here where you can no longer go up, then you begin to slope. So as you slope, you begin again to climb. As you climb, you come back to a slope, and then you reach a point where you look sometimes things continue in a normal, not positive, not going up, not coming down. So there are 3 stationary points in this graph. If you look at, you find that when you move from here up to here, we say we are moving positively. As you raise up, we are moving positively. So, and then as you slope down from here, you see that this curve is looking down. It means it is a maximum turn. You have made a maximum turn from positive down to the negative. And then when you reach here, this part, you will find that it looks up. It is in the form of a U. So it means that you from the negative here, you will move upward, but at a point, a fixed point here. So this one simply represents the minimum stationary or minimum turning point. And then somewhere here, when you come here, you find that the curve is no longer coming steep down, or it is no longer going up at a steep level. So at this point, we say the curve is just a balance, a half. So that is what we call a point of inflation. So we simply say the stationary point The stationary points are in three categories. Three categories. They include, the three categories include: 1, we have maximum points or turn. And then 2, we have minimum points or minimum turn. And then 3, we have point of inflection. So those are the 3 main categories of stationary points. We have a maximum, we have minimum, and then the point of inflation. So this is how a curve moves. You can move in a maximum point, or you can one day come to a minimum or inflation. So NB, take note of this, because sometimes in your papers they say the stationary or find the critical points. So you say the stationary points are also known as critical points. Critical points. So, my dear learners, sometimes in your papers or in your exams, they may avoid to say find the stationary points, but they will say find the critical points. Critical points is the same as a stationary point. It is a dangerous point. It is a point where the gradient is equals to 0. So when you reach to that, you turn to that level, then it becomes a critical moment for you. So in summary, I want you to have this in your summary so that you don't, what we mean, how do I get a maximum turn? How do I know that I'm at a maximum turn or maximum point? Summary. So you need to know, how do I get a maximum? How do I know that this one is a maximum turn and this one is a minimum turn? How do I get a maximum, or how do I know that this one is a minimum? So you draw this on your books. So you draw this one on your book so that it will help you easily to identify. Say here, type of turning. Type of turning. Gradient to the left. Gradient to the left. gradient to the left, gradient to the left, and then we have gradient to the right, gradient to the right, to the right, the gradients to the right, and then lastly we have the shape of a curve, a shape of a curve, a shape of a curve. So what happened here, we have three type or categories of turning points. So the first one, we shall have a maximum. So what happened to the maximum? The gradient on the left hand side will be positive, and then on the right will be negative. And then which type of a curve will it show you? It will show you a curve in that nature, like N. So that is the kind of a shape of a curve. And then we have minimum. On the light, the gradients to the left will be negative, and then the gradient to the right will be positive, and then the shape of the curve will be in form of a U. So that is the shape of our curve. And then we have points of inflation. So this one we have in inflation, it is in two ways. Sometimes you may find all right is positive, left is also positive, and then you may also find right is negative, left is also negative. So you find that in that kind of a change, things are a bit balanced. It may be positive throughout, or it may be negative throughout. So here you will find it is positive. Here will also be positive. And then the kind of a curve that will be given us, it will be in that nature. And then if it is negative inflation, if it is negative, then we find left is negative, right is also negative, and then we shall have in that nature. So that is how, in summary. So whenever you are calculating and you find that the gradient changes from positive to a negative, then you will automatically know that the shape of my curve will be upside, meaning it is now maximum. I've reached the maximum point. And then in case you find that the gradients on the left changes from negative to positive, then you will know that my shape of a curve will look up, like in a U. It will move up. It means now you are in a minimum turn, and then inflation will be of that nature. So from there, let us look at how do we find these curves. How do we get identify the stationary points. Identifying the stationary points. So, methods of identifying the stationary points. Methods of identifying the stationary point. Identifying the stationary points. Methods of identifying the stationary points. So, class, there are only two for your level. There are two methods of identifying the stationary points. There are two methods. One, you can identify the stationary point by using what we call the first derivative. And you remember that last time when we are looking at a derivative, what does it mean? It means that you are to differentiate the function given. So after differentiating, what will be the outcome of that function or that differentiation? And then if it comes out is the gradient 0, if it is 0, then you automatically know this is a stationary point. And then you also want to go ahead. What will happen? What has happened to my point? As the gradients changed from positive to negative, and therefore if it has changed like that, what will it be my turning point? My turning point will be a maximum. We use the first derivative. Using the first derivative, is one way of identifying the stationary point, the first derivative. Then two, using the second derivative. Using the second derivative. Using the second derivative. Using the second derivative. So those are the two methods that we can easily use for identifying the stationary points. Then now we say, let us see how do we use the first derivative in identifying the stationary points. The first derivative. The first derivative. How do we use the first derivative? So the first derivative, in identifying that what has come out is a maximum turn. So you say maximum point of a function. Maximum points of a function. Say f equals to fx at x equals to c, at which f dot or dy over dx equals to 0. So you may look at this. How do we use the first derivative specifically on identifying the maximum turn when the gradient is at 0? because we shall use the first derivative, identify the maximum, the first derivative, identify the minimum, and the first derivative, identify inflation. Before we go to calculation. So, we can have this table. So we say this be x, and then we have f1, which is, or you say dy over dx, and then we shall have the function of x. We have x is less than c. X is less than c. And then we have f of c. And then we have x is greater than c. So we have f, the gradient here will be greater than 0, and then here shall have equals to 0, and then here we have less than 0, and then the function, what happened? It means it is increasing, and then here it means stationary, and then here it means decreasing, and then you only have this kind of a curve. I will explain once. Let's see. Say this is sketch of maximum, sketch curve of a maximum point, sketch curve of maximum points, So it will look in that nature. We shall have it in that form, and then we say this one are our points. So here you will find f is less than 0, and then here we find f1 is greater than 0, and then here we find f1 is equals to 0. So this is a maximum turn or maximum points. So learners, if we are asked to identify a maximum using the first derivative, we shall have this kind of a table. We have a table. This part here represents the x, the value of x, and then the second row represents the derivative or the gradient, and then the third one represents the function of x. So what will happen if x here c simply stands as the value or the function or the polynomial given to you, or the value of the number that is given to you. So if we differentiate and we find that we have the gradient f1 here, means the gradient is greater than 0, it means that if the gradient is greater than 0, the function is increasing. It is going up. And then if the gradient here is equals to 0, it means that the function is at a stationary point. And then if the gradient is less than 0, then it means the function is decreasing. And therefore, in summary, you look at our sketch here. You find that from here, you move from left, it is positive. Left is positive, and then right is negative. It is less, meaning it is decreasing from this side and it is increasing from this side. And then it reaches this point before it begins to come down. And then this is what we call a maximum turn. So, our dear learners, for now, I would like us to stop at this part. Then we shall continue from the next lesson how to use the first derivative in identifying the minimum and then inflation, and that marks the end of application on stationary point. Thank you very much. I wish you the best. Goodbye.